Hello everybody, welcome back to high school tutoring, and today we're going to be learning thrown up. So this time, instead of the ball going immediately down or going down, instead we're throwing it up. So here's our ball. We're going to have this like that. There's our diagram. So the ball is being thrown up and it's going up, down. So this time our gravity is going to be negative 9.8, because if we look here, we don't have a V naught of 0, so our V naught is always going to be positive. V naught is always positive now for us. And so if gravity's always going down, then that means a negative and a positive oppose each other. So we're going to have a negative G value. So that's why we have negative 9.8. Our V naught, same thing as thrown down. It's not going to be 0. But now we have a new value, V final. So if we're ever finding the exact top point, which would be over here, our V final, before it goes back down, it's always going to be 0. So you can imagine this as if like a parabola, where there's the top point, which you call the vertex, and then when it starts going down after the top point, it's changing. And this is when we have gravity as positive, or this would just be a drop problem. So this would just be a drop problem for after this, if that makes any sense. That would be plus, and that would be plus, so we're just going to have a plus value for G. So I think that helped a little bit. But we can find how high this is. So let's say if our V naught is 3 meters per second, right? And we don't have time, but we have gravity. So we could do D equals V final squared minus V naught squared over 2G. So this is just a simple problem that doesn't involve time, since we don't have a time value that we weren't given. So, and V final is 0, so we can just cross this out. And so D equals negative, and then in parentheses 3 squared, because we're squaring the 3, not the negative 3. So if that makes any sense. And then 2 negative 9.8. Done. And then if we just go to our calculator, let's say I have mine right in front of me, we could do negative 9 divided by negative 19.6, which is all that math, and that is equal to 0.46 meters high. So yeah, it just went up 0.46 meters, and yeah, that's it really for this example. If we're just finding up to here, and then if we want to find down here, all of these are always symmetrical. This graph doesn't look like it's symmetrical, but it is. So our V final for this is going to be 3, because if anything's going up by the same amount, it's going to go down by the same amount, because it's an even parabola. So our V final would be 3. And if we wanted to find, and also our displacement, which is our distance away from the original point, is also 0. Or it would be 0.46, and if we just double 0.46, not 0.44, my apologies, just do that, just pretend it's 0.46 and not 0.44, let's multiply that by 2, that would equal 0.92 or 1 meter total. So that's how we can decide where exactly we are. So that would be the total distance, so that would be this up, which would be 0.46 meters, and then this down, 0.46 meters. It would be the exact same thing. And yeah, so let's get on to our practice problem for today. Jack throws the same apple up at 5 meters per second. He throws it up from the same 25 meter roof. Assume that the ground is negative 25 meters and the roof is 0 meters. What is the maximum height the apple will go? So maximum height, that is finding for this top point up here. So let's use our givens. Let's put our givens down. So we know that D is what we're looking for, so we can just leave that out. We're going to know that V naught is 5 meters per second. G is obviously negative 9.8, as we've explained here, where the V naught value is positive and the gravity is going down, so it's opposing it, which makes it negative. So we can just have meters per second squared, and then we can add V final here, because if we're looking for this top point, V final is always 0, so we don't actually need this up here. And yeah, we can just use the same exact problem here. that we just used. D equals v final squared minus v naught squared. And it's the exact same thing, 2g. And we can just plug this in. So d equals -5. You could solve this if you want with me. So -5 squared in parentheses over 2 -9.8. There we go. That's exactly what it is. So we can just solve that really quick in our calculators. So that would be -25, doing some simple math. And then divided by 19.6. Or -19.6. But these negatives will cancel each other out, so it doesn't really matter. So that, you could just do positive if you wanted to. But that would equal 1.28 meters. Or 1 meter, it doesn't really matter. I think we would go with 1 meter because, or 1.3 meters even, because of sig figs. So yeah, 1.3 meters. Also, that just went completely off screen. Yeah, so 1.3 meters. That is the maximum height the apple will go. So I'm just gonna open up a new tab that has like the other parts of this problem, because I just wanted to show this as like a little brief like explanation of how you can do thrown up problems. So we have the same thing, and we obviously know that that this obviously is 1.3 meters as the maximum height, as we did the problem back on the other page. So now, part B, how long does it take the apple to reach its max height? Alright, I'm gonna let you guys in on a little secret. We have some quick shortcut problems that we could use. So if we want to find t, we could just use the problem v final equals v naught plus gt. And then when we isolate for t, subtract v naught, so that's v final minus v naught over g. So that's it. And since v naught is negative, we'll have negative v naught. And since our gravity is always negative when we're just going up, we'll just have negative g. That's pretty simple, isn't it? So we can just cross those negatives out, because two negatives will cross each other out. And then we just gotta do 5 over g. 5 over 9.8. And there we go. 0.51 seconds. 0.51 seconds to reach its maximum height. So now here's the problem that is going to get a little more confusing. How long is the apple in the air? So we need to find the total amount of time that the apple's in the air. So we're given that our displacement is 25. Well, now we have 1.3. So I'm going to explain this as if I was doing it on my own right now. D is going to be equal to 25, as we have in the problem, plus 1.3. Now I'm going to explain this right now. So if we're finding this maximum height, this counts because the apple is going up still. The apple is still going up. So when it goes down, we go 25 meters below the roof, so we're going all the way down to -25. So this entire bit here is 25 meters, but we also have 1.3 meters because that's what we got over here. It went up 1.3 meters and then is now going down to whatever that is plus 25. So just add this is 26.3 meters. If that explanation made any sense, I hope it did. I think it makes sense to me, but I don't know, some people might not understand it. So yeah, just come to me during school, ask me a question or something. I'm perfectly fine with answering them. So yeah, so we have the total time, and this time our v naught is 0 meters per second. Our v naught is now 0 meters per second. So if our v final, when going all the way up here, if this is 0, we're now using this entire amount of displacement. So this entire thing is now 0. Well, the v naught is now 0, because now we're just doing a drop problem at this point. Drop problem, find a free amount of time at 26.3. Now there's one more step that we're gonna have to do. Our time is gonna be whatever this is, so we actually don't know what that is, plus 0.51. Now let me explain. We want to find the total time in the air. How long is the apple in the air? That is going to be the total time. So this includes going up and going down. So this is to go up, so that's 0.51. If this is to go up, we're going to have to include this, because then here There's no point, because then we're missing a little bit of time. We're just cutting this bit out, and that doesn't matter. So whatever we get for t for this drop problem is just going to equal 0.51. That's pretty simple. So realistically, we don't have v final, so we can't use this problem, right? But we do have a couple other problems that we could use. So we could use d equals v naught t plus 1/2 gt squared. Or, since v naught is 0 now, we're just going back to dropped. This entire term crosses out again. So that'll just be d equals 1/2 gt squared. And then if we just isolate for that, so we'll multiply by 2. So that would be 2d and cross out this 1/2. So that's 2d equals gt squared. Okay, so then we just got to divide by g. Okay, so that's now 2d over t squared. And then just find the square root of t. And there you go, that entire thing. Whatever we get for 2d over g will now be square rooted and equal to t. Pretty simple. Just the same as drop problems. Just now we just have to add this final bit at the end of it. There is another way I could solve it, and I will explain that in a minute. But let's just quickly do this method because I think it's pretty simple. So 226.3 over 9.8. Now our gravity is now positive because we're going down again. Our v naught is our velocity is technically going to be considered negative here. Technically our velocity is going to be negative, but also our gravity is going down, which is also negative. And two negatives will make a positive. So these two, once they're combined, will be considered positive. So our g is 9.8. And then we can just plug this into our calculator. Pretty simple. So 2 times 26.3 is 52.6 divided by 9.8. We get 5.36, and then we find the square root of that. Or 5.37, it's one of the others. And we get 2.32 as our answer. Well, that's what I got. You might got a little bit different. I didn't round anything before solving for the square root. So I get 2.32. 2.32 seconds for this dropped portion. For this portion going down. Now, of course, we got to add the 0.51 because this is still part of the problem. So 2.32 plus 0.51. That is going to be 2.83 seconds. And that's our answer. That's part C right there. 2.83 seconds. That is our total time. And I'm going to explain this other method now. So for our other method, we could have used this exactly. So we could have solved for this entire portion. So let's draw a little line separating this bit. So let's say this is d equals 0. Let's say this is the roof. He is throwing it up. It goes to its max height, which we know now is 1.3 meters. And then it drops down and we go here. So we know our v final is going to be 5. Because remember, the parabola is going to be equal. So if our parabola is equal, that means our v final is going to be 5 meters. 5 meters per second, yeah. And we could just double this time. Because remember, if it's equal, this is 0.51. Add this is 0.51. So this is 1.02. Right? Or no, 1.2, not 1.02. Actually, it is 1.02. Okay. So that's just 1.02 seconds. And then we could just solve for this. This is like a thrown down problem. But it's pretty simple. This one involves quadratics, so I'm not going to show the entire thing. So yeah, we'll just do d equals v naught t, in our case, which is 5 now, plus 1/2 gt squared. So obviously I could just infer what we're going to get here. So I just got to do 2.83, which is our total time that we found, minus 1.02. We should get 1.81 from whenever we did this quadratic. So 5t, and then this would be 4.9 t squared, and then this would be 25. So yeah, we just have that. That's another method. You could solve for this quadratic. Maybe I'm right, maybe I'm not. Should be 1.81, the answer that you get, and then you just add this to the 1.02 and you get the same answer. So it's pretty simple. And now D, what is the apple's velocity right before it strikes the ground? So we could actually use a very simple problem. We're going to use the same thing that we did here, but instead of finding t, we're just going to find v naught. It's v naught plus gt. Now this could be very helpful if you did this solution, because then we'll just know that our v naught is 5, so we can just add that here. But v naught is 0 because we did all the way up here. And then time, we know, is now not 2.83. Here's where this gets confusing. 2.83 is the total time it's in the air. But now we're starting from here again. We're starting from up here. So we're just going to use 2.32. So our time is now 2.32 seconds. And then our g, obviously 9.8, is going to be positive, again, because it's a drop problem. So yeah, we could just solve this right here. So v final is equal to 9.8 times 2.32. And then we could just do this now. I'm just going to do this here. 9.8 times 2.32. 22.736. So that will be 22.74, I believe, if I'm right. Yep, 22.74. Okay. Okay, my cursor's over here. And then yeah, that would be our answer. 22.74 meters per second is our v final. So that's it. That's all we had to do. Now, obviously, as there is a second way, there is multiple different ways you could actually do this. There's a third that I'm not too fond of. I'm actually not too interested in doing that. But I could explain it if I just need to get some tips from my teacher to know exactly what to do for that. But yeah, that's really it for this video. I hope everyone enjoyed. I hope you guys enjoyed, and maybe you learned something, because this is a topic that actually could be very useful, especially if you want to know like if an accident were to happen, what is the force that it would drop at? Like that would count like air resistance and other stuff. But besides that, if there was no air resistance and we didn't know the weight of the object, this could be perfectly fine. This is a perfectly viable solution for any of these. So yeah, I hope everyone learned something today and enjoyed it. So I'll see you guys in the next one. Goodbye!